Hi everyone, welcome to day 3 of our Out of This World theme. So today we're going to read a book called A Computer Called Catherine by Susan Slade. Everywhere she went, Catherine counted. She counted her steps to church. She counted the plates on the dinner table. She even tried counting the stars in the sky. Most important of all, Catherine counted the days until she could start school. Finally, at age 5, she followed her brother hundreds of steps to the 2-room schoolhouse. An excellent student, Catherine devoured thick books and added numbers at the speed of light, so the teacher decided she would skip first grade and start in second. But Catherine was such a fast learner, she later skipped 5th grade too. And before you could say mathematician magician, she was a grade ahead of her older brother. Catherine finished 8th grade when she was only 10 years old, but her town didn't have a high school for black students. Determined to keep learning, she counted the dusty miles, 120 in all, as her family moved closer to a school she could attend. There she took an exciting math class called geometry. She learned how points and lines made shapes, triangles, trapezoids, and perfect parallelograms. And her love for math grew exponentially. At 15, Catherine started college. She flew through every math class at West Virginia State, so a professor taught harder classes just for her. In advanced geometry, she plotted points on a graph. When she connected the points, they created a beautiful U-shaped curve called a parabola. So that's what this is. It was love at first sight. After graduation, Catherine became a math teacher. Back then, people said women could only be teachers or nurses, but Catherine knew that was wrong as 10 minus 5 equals 3. She believed women could be anything, scientists, lawyers, or mathematicians. So she set out to prove it. Catherine discovered a research center in Virginia that was hiring women mathematicians. They were called computers because they made calculations that helped the men engineers design airplanes and flight planes. To Catherine, it added up to the perfect job. All day long, she punched buttons on a calculator just like the other women. She solved long math equations just like the other women. She wrote answers on a huge data sheet just like other women. But Catherine wasn't like the other women. She asked questions, lots of questions. What were her calculations used for? Why were they important? How did her answers help design airplanes and flights? The men engineers noticed the women who asked intelligent questions and how quickly she solved difficult math problems. So they asked Catherine to join their space team. Its mission: send America's first astronaut into space. Catherine said yes. Then she discovered that women weren't allowed to attend the group meetings. She knew this was wrong as 5 times 5 equals 20. So she asked if she could go. Women don't ever go to those, the engineer said. Is there a law against it? Catherine asked. Well, no. So Catherine showed up at the next meeting, ready to work. Astounded by her geometry skills, the team asked her to calculate when America's first space flight should blast off. Catherine agreed, but first, she had some questions. Where should the rocket splash down? How high should it fly? When should it land? With that information, Catherine carefully computed the rocket's flight path, a beautiful U-shaped curve. Next, she worked backward to figure out the time it should blast off. Then she began counting the days until launch. On May 5th, 1961, Alan Shepard blasted off. Following Catherine's flight path, he soared into the silvery sky, and 15 minutes later, he splashed down in the Atlantic Ocean, right on schedule and right on target. Soon, Americans began dreaming of a longer flight around the entire Earth. To figure out the math for this long, complicated trip, engineers decided to use their new room-sized computer that worked much faster than people. But astronaut John Glenn trusted Catherine more than a machine. He wouldn't step 1 foot onto the rocket until she said the computer's calculations were correct. Happy to help, Catherine checked every single number. On February 20th, 1962, John Glenn became the first American to orbit Earth. Then people began wondering if an astronaut could travel all the way to the moon. Both the Soviet Union and the United States wanted to be the first to land there and win the space race. Catherine knew this flight was incredibly long and dangerous, and every calculation would have to be perfect. One math mistake and the rocket would zoom right past the moon. Yeah. As NASA's computer hummed and computed a flight path to the moon and back, Catherine went to work too, double-checking the machine's calculations. But this was the most complicated geometry problem she'd ever seen. One of the points, the spacecraft, was flying incredibly fast. Her target, the moon, was constantly circling Earth while also spinning. Some people thought the problem was too difficult to solve, but Catherine knew that was wrong as 25 divided by 5 equals 4. She calculated and computed and plotted and planned. She created a bold, brave path all the way to the moon and back. 10, 9, ignition sequence starts. Heart racing, Catherine leaned close to the small television screen. 7, 6, 5. She held her breath as powerful flames exploded on the launch pad. 4, 3, 2, 1. Lift off. The rumbling rocket slowly rose above the ground, above the smoke, above the clouds, and then disappeared into ink black space. 4 days later, as Neil Armstrong took his first steps on the moon, Catherine smiled and began to count. Girls are capable of doing everything men are capable of doing. If you want to know, ask a question. There's no such thing as a dumb question. So there's proposed flight path for Alan Shepard's space flight, then picture of Katherine Johnson, and then a NASA report which was co-authorized by Catherine, and then the proposed flight path. So to go with our story today, our activity is going to be making a rocket. So what we did is we colored one of the rockets and then cut it out, and then on the back we cut out a piece of the white construction paper and glued the sides. I had to use a little bit of tape at the top, but glue the sides down so this was all closed, and then you take your straw and put it in the end so you have a rocket. And then when you blow on the straw, should work. Let's try it again. Maybe. No? There we go. Let's see. There you go. And then you have your own rocket that can lift off. There we go. So I hope you enjoyed the story, and I hope you enjoyed doing the activity, and I'll see you tomorrow. Have a great day.